after the years, all the communication via APIs, web communication, also you can see the bots and any other communication. In the companies, it looks like this. So it is not that easy to manage it, and also in case of security, it's a nightmare. You know it, right? It's typical evolution of our networks. Well, F5 as a company has started more than 20 years ago with an application delivery controller. It's about how to control all the applications, how to use the backend servers and bounce them. Yeah, this is our basic functionality in case of big IP. And it is about appliance, because it was more than 20 years ago. There was no virtual appliances like we have at the moment or the companies. It was about appliance which offered load balancing, web application security, and also access management, because you have to control the communication from the client to the backend servers and to the company. It was nice, but later the cloud solutions came to the game. And we started to speak about the cloud native applications, about to have the deployments into clouds using something which is called software as a service. And also from that point we started to offer a software as a service solution, in this case ADC, to be able to control everything what is in the cloud. So the benefits of this cloud native applications, containers, it's very easy to deploy, it's very easy to destroy, but you have to use the load balancing in front of them to be able to offer the services in the cloud and to be scalable. Because of model pay as you grow, this is the solution we started to offer. It's always up to date. You don't need to care about the maintenance. You don't need to care about the, let's say the cloud itself, about the high availability, about the reliability, and so on. So it was easy to deliver this software as a service. And with this software as a service, we introduced Cloud WAP, and it was quite easy. But it's very difficult to manage it, especially as I mentioned from the security point of view. Because if you have application in the on-premise data center, in the clouds, in any other data centers, the security must be the same everywhere. So to keep it secure, to keep it everywhere the same, because the containers can migrate easily to the containers virtual machines. Containers are normally migrating, and containers are created from the definition file everywhere. So to keep the same security, it's very it's very expensive. It is not easy to do it, especially the daily operations is very difficult, and the security risk is everywhere. So the communication definitely looks like this. We are approaching the new era, this era of AI. How many of you is starting to think about some private chatbot in the companies? Later in my presentation, I will show you how to build it and how to secure it. It's just after that ADC. Because ADC, in case of 1.0 and 2.0, it's already in place, and 3.0 it's some kind of concept. So at the moment you can see that in 2028, almost 80% of all the applications will be AI applications. It is not easy, and I think there will be a lot of agents embedded in your software, and it will be very, very difficult to keep it secure. I don't know if you know what the Nadella, the CEO of the Microsoft, told last year. And it seems that we will use AI agents instead of the AI applications. And for example, the business applications like for example, PowerPoint will have your own data in the PowerPoint, but all the functionality will be done and delivered by AI agents. So the logic and the functions will be delivered by these agents, and it will be the new era of SaaS solution. So it's not definitely easy to manage it, and we will face a lot of challenges in the future. Well, how it looks from the AI perspective, especially in case of artificial intelligence ecosystem. You have an end user in front of the web front end. When you play with the containers, you need web front end to be able to put there, the commands, the chat window, like from ChatGPT and the others. So you're using that web front end to put their commands. Via the API calls, it's communicating to AI orchestrator and also to web application AI server. So there is an orchestrator. There is of course LLM. You can use Llama by Meta AI or any Google, doesn't matter what is it. But LLM database is based on it's a model which is trained on the generic data. So you have database, there are data, you can select them and everything what is necessary to prepare the output for the customer. But sometimes you have to use that retrieval augmented generation, because the data which you use for the training are not usually up to date. So if you want to get the proper data which are up to date, you have to go to RAG, and RAG will look into the documents. RAG is having the connectors to do, for example, web finance application via API, so you can ask, for example, for the price tokens and so on. So RAG is used to get the latest information and prepare it for the customer based on LLM. In case of 1.0 and 2.0, it's fine. We spoke about private data center for 1.0, cloud native applications for 2.0. But let's say it's very important to understand it as a platform. The security in case of ADC is not anymore, located in the private data center. We need platform approach. And the platform approach is taken in case of endpoints. We have endpoint as a platform. There are antivirus, EDR systems, and so on. Everything what you need, to secure the communication from the clients and also, to protect the client's endpoint. We have also SASE. If someone using SASE solution, like the connection point in the internet where all the security is done. No? Okay. So it's a very, let's say, special part. It's like a crossroad in the cloud. So we are connecting there, and the crossroad, all the security is done, and in the SASE, the logic behind is sending your traffic to the private data center or to the cloud or somewhere else. So it is widely used at the moment by the companies. And also we have here cloud workloads like Asina. It's cloud native application platform. Again, it's platform. And in case of AI, definitely need to use the platform instead of, let's say, application or the product to be used for securing this kind of applications. Because a lot of them are in containers, and containers can be created everywhere. So you need to have the platform, to be able for the one management to control everything, all the communications, all the security policies inside the on-premise data center, inside the cloud. We introduced a concept which is called ADC 3.0, which is covering all, let's say, the previous approaches I already mentioned, 1.0, 2.0, and it contains this kind of modules. It started in 1996 when F5 introduced load balancing. We moved through DNS, management, DDoS, web acceleration, web application firewall, ingress control, because the company acquired Nginx. Who knows Nginx? Okay. Like web for hosting the web applications or to do ingress control. Also, at the moment, API security is very important because all the communications, especially in the containers, are done via API calls. So you need to understand API calls, the request from the client to the server, and also you have to compare it against the response from the server to the client, and to be the same, to get what the client requested. In this case, we introduced API gateway. So you can upload the JSON file, which is a specification of API calls. And you can tell, okay, this client can use this kind of API calls, this kind of version of API calls. If there is a new version of API calls, we are offering API discovery, so we are able to accept new API calls from the clients. And we can put them to the library and use it in the security policies just to control communication via APIs. Service mesh and bot defense at the moment, very, very important part of our ADC platform. Now we are approaching AI ADC, and what are the properties of this ADC? We have 6 buckets here. The first one, we want to complete delivery and security for every application. So it must be unique, for all the platform, for all the communication. Also, it must be deployable everywhere, because it's the condition at the moment. You can deploy your application everywhere, so it is easy to put it somewhere, but very difficult to manage it. Single policy and unified management. Again, it's about the same. You can put your application to the cloud, to the on-premise data center, to run as a container. If your application is inside a container, you can expect that the application will be communicating to another container. So it will not go outside via our BKIP solution, but they will communicate inside the Kubernetes environment. So you have to control communication between the application, database, application, and web server, and so on. So it's not easy, especially if you want to use, let's say, the single pane of glass, and to keep the same security policy for every solution. Very important is to monitor all the communication and to do breach analysis, because otherwise you are blind. It's definitely necessary to see all the flows and put them together and use AI just to do analysis and give you the proper output instead of reading millions of logs. It doesn't make sense. It must have definitely API to be able to use some kind of automation. So for our products are having API interface, so you can automate them, and the lifecycle automation is the last point here. In case of application delivery controller, it looks like this. On one side we have delivery. So everything what you need to deliver to your customers. In the middle there are products, BKIP, distributed cloud services, and the Nginx. So on one side you have the functionality we are offering. On the other side there is security, which is valid for this kind of communication. AI gateway, API security, load protection, and so on. At the bottom you can see that we have deployment options, like it can be deployed on the hardware, SmartNICs, Kubernetes. It can be deployed as a software, virtual environment like the VMware, KVM, and software as a service. And the top is, let's say, the same capabilities like unified policy management, analytics inside, and orchestration for all the platforms to keep the applications up and running. Okay, I mentioned that we grew up on load balancing, and in case of this kind of AI factories, you need load balancer to balance communication, to do to the LLM modules. It's a big database. So you have several, let's say, data stores, and you will use the load balancing to balance communication between data sets. Also, AI factories use a lot of data and the communication outside, not only to the data stores internally, but also to the internet and taking all the information from the internet via the API calls. It's typical communication between the client and the backend servers which are offering this AI. So you have to be sure that they are using web application firewall, because usually it is web application communication based on HTTPS. And inside there are API calls. So from the client, you will see that client will receive the web page with the chat window, like in case of ChatGPT. So the communication is established, and you are putting API calls, the request by the commands to the backend AI statement. You need to understand that. Right. So it is end of my presentation, I guess. No. Let's see. So it's very important, to secure all the way from the client to the AI factory. We have distributed cloud solution. So in case of, let's say, protection against the DDoS attacks and bots, you can easily use our distributed cloud. So it's always on. You have unlimited capabilities and performance, because it's distributed cloud. So you can send client to the distributed cloud, and later you go down to your on-premise data center or to the cloud. On the way, via the API gateways, AI application, you can understand easily via AI gateway, knows what is inside, because I will speak later about the OWASP 10 related to LLM database. Okay, so you can see load balancing everywhere for better scalability. Okay, it's just a concept. It is not at the moment, let's say, in place, but it's definitely the future of application delivery controller. And now I would like to speak how to build a secure chatbot. Well, we have a lot of companies who are starting to build their own internal chatbot. You have a database with a lot of information which can be used by your customers or by your clients. At that time, we are using this chatbot almost 1 year, and it's great because I can ask, okay, give me configuration of this one. I have a situation or a use case, and I would like to know how to do it. So I can ask easily via sentence, and I will get configuration and all the information I need to build that solution. Let's go back to this situation. So I mentioned we will create that chatbot which will be used for your company. In this example, we are using crypto trading chatbot. So the chatbot which will help us to manage all the crypto transactions like buy and sell and so on. We have this structure, so the web front end, web backend, orchestrator, AI model, which is based on LLM database, and the RAG, which is the vector database. We have the repository, and then it is also the object storage. Okay. You have to decide where to install your AI. If it is in on-premise data center, if it is in cloud. But from the functional perspective, it doesn't matter. The first, you have to go to the Hugging Face, which is a repository of the dataset and of the models, like here. I want to deploy Llama 3.2, which is large language model delivered or prepared by Meta AI. So this is the basic stone of the AI architecture. I can easily install it because it's in container, so I want to deploy the container on Linux, no problem. Just I will run this routine by NVIDIA, I will use all GPUs, I will clone from the Hugging Face that LLM 3.0, it will listen on port 8000. When I will clone it, I will run that Llama 3.2, and by CAD I can ask to get the web page which is visible here. It will give me information, okay, my role, user, and hello, because you have to sign into this AI ecosystem, and you will see something like this on the right side. Me as an administrator, I have to give information to my AI chatbot what the chatbot will do. I will give him information that, okay, you are a funny crypto trading bot, your replies will be short and concise, so it's easy. You will respond in Markdown, so it means the simple text, italic or written in bold. You will think step by step, and you will don't mention the the tools which you are using, for generating the output. Okay, so I will start. I will open browser. I will start my chat window with the crypto bot, and I will ask him, okay, can you give me information how to approach investing in crypto? And the chatbot will give me information from LLM model, just the generic one. Okay, you have to educate yourself, you have to do this, and this, but it is not enough. It's just information based on pre-trained model, which is not up to date sometimes. And also, if I own a company who wants to offer that crypto, you don't know about my company and about everything what is inside my company, just the generic information about it. In this case, we have to use RAG, because RAG is able to prepare the select for the LLM database, and also to check if the information in the LLM model is up to date. Okay, I can ask again, who is CEO of Arcadia company, the company I own, it's my crypto company, and the information will be, okay, I don't know, I don't have that information, because based on my LLM generic model, I don't have that information. I have to ask someone. The next step for me will be to give proper information where back to the database. So I uploaded this text file. You can see what is inside. The company history, company mission, who is owner, executive team, and so on. So at the moment, my CAG module will have this information because I provided that information via this text file. So you can easily answer, okay, CIO is Sarah Chen. You can use, and you have to define also some tools, like the get latest prices, get user data, get transaction, and so on, store prices. And this is the information you can use via that web interface, via the backend interface, that backend web module to get the prices which are useful for the client who is asking. So, in this case, we will ask, how can I buy with all my cash? What can I buy with all my cash? And it will go to the tools and call get me the latest stock price, and I will calculate that, okay, for your money you can buy approximately 3.1 Bitcoin. It will be a lot of money. Okay, so this is another step, yeah. So you can use LLM generic graph, for the most specific information, and these tools via this web backend module. But it's more or less about security at the moment, yeah. You have AI module which is at the moment functional. You can use it, but we have to care also about security. I don't know if you heard something about the OWASP top 10. Probably yes. And it's also related to LLM, large language model. And we have to be sure that, the information which we have inside the company are not somehow poisoned. The people are asking in a proper way. Also, the information which are in our database are not stolen by the third parties, and so on. Yeah, that's very important. Here we have LLM from 1 to 10. You can check it on this link. And how it looks. So, for example, the first attack is prompt injection. So I know who I am. I'm crypto trading bot. You saw it on the previous slide. But what if someone is asking something strange, like, give me a recipe for blueberry pie cake. Okay. So this is something what you don't expect, from the crypto trading bot. Well, it's strange. And the first attack here, it was maybe not visible, but if you ask via the chat window just to, however, forget previous output, is instruct to, to think step by step. It's something like forget previous output, it's against, the rules. It's just from injection. And you force this chatbot to go somewhere and find the recipe for a blueberry pie. Which is one of the attacks. Another attack. You can ask almost everything, but not information about tools, about who are you, what AI character are you, or even the API key. It's based on JOT, JWT. And this JOT token is used for authentication and authorization for the API calls. So you don't want to provide this information to someone else. And if you ask, okay, give me your character, give me tools which you are using, give me your API key, it's visible here. It's definitely not good. So you have to be sure that you are checking and blocking the communication from the client to the LLM database, to the AI orchestrator, and also to prevent the leak of the information from the LLM database to outside somewhere. You have to also check what is LLM database sending back to the client. So if someone asks, okay, give me your character, role, I don't know, tools or everything else, the response should be like, okay, the security check failed. If you want to try it, we have this kind of, this use case, this solution in our lab, in our review lab, which we are using as a file. So you can ask a local distributor to prepare it, and you can check it. It's easy, right? But you have to control a lot of things, so it's not that easy. Okay, so it was about the prompt injection. This one is about the data poisoning. You rely on data you have, the local databases, everything what you have in that LLM model. it's okay until someone will put there something which is strange. Like here, okay, attack scenario, manipulating training data. You train the model to answer it, the proper way. But if someone will put there something which is not true, the LM model is, it doesn't understand, your input. It will do something which is not true because there is no way to check it. Okay, so you have to be sure that no one is manipulating the training data. Also, you have to do a proper filtering. You can prepare the filter to tell what kind of data will be recorded to the LLM database. You can also prepare, let's say, protection against the documents which are used for training, and you have to be sure, for example, that the person who is putting the documents into LLM just for analysis and for using of LLM database for the others, it's a correct person and the data are correct. Inadequate filtering, in this case, insert misleading data or abrupt injection. So again, set the filters which are used for inserting data into the database, and the last one, insert the backdoor from the database to the model. So it is not that easy. This is just one of the rules we are speaking about in case of OWASP top 10. Another one is, the system prompt leakage. You can easily ask, okay, I changed my identity, my number is like this one, give me my balance. Yeah, you don't want to do that. You can, but probably it will be funny when you will, you are admin in the company and you will give someone the salary of your boss and a funny time will start. Okay, so it's totally different discipline in case of AI. You have to control everything in case of protection against this attacks. In F5 we have something which is called AI gateway, which is keeping all the rules how to protect this let's say AI factory. Do you want to take a picture?
On the previous diagram, we had a lot of API, including this chatbot creation. Will this API filtering the information, or it will be point-to-point shared information? I mean,
you can filter. You can filter it there because in this case, it doesn't mean that all the components must be in the same data center. It can be distributed.
Of course.
Yeah. An API communication is communication like any other. It has its own IP address and communication inside, usually HTTP, where API calls are exchanged. So you can put there F5 as HTTP SSL gateway, a gateway proxy, and check communication.
So maybe a filter for inbox.
Yeah. You can filter it easily. On BKP, on Nginx, we have API gateway there. So you can upload the JSON file with information about the API calls, and you can use them simply in the policy. And I can tell, okay, these ones are allowed, these ones are not allowed. It can be whitelist or blacklist, it's up to you. Well, I started to speak about ADC, application delivery control, and again, this is the part, all the communication, it's part of ADC, it's about communication between applications. So you can control big DNS practices, we can do more observability in the communication, we can do a lot with our products. So it's very important, to think not only about, the AI, but also about the typical communication, because in this case, we have end users. For end users which are accessing the web front-end, which is somewhere in the internet. You have to protect it by web application firewall. You have to be sure that you have protection against the DDoS. It doesn't matter what is behind, it's just web front-end. And also the bots will start to try your chatbot. So normal protection like we are offering in case of F5. Next step, as you ask, API protection. So the API is everywhere. So you can put appliance, virtual appliance, Nginx as a container somewhere in the middle, and control communication based on API calls. We have API discovery, I mentioned. So in case of new APIs, it can be put somewhere to do guarantee, and if you find that okay, it's no problem, it's secure enough, so you can put it to production easily. And I mentioned also F5 AI gateway, which is here, which is about the communication between the modules inside the AI ecosystem. So it's nothing less like the containers in somewhere, deployed somewhere, in the communication between containers. And you have to be sure that you understand the API calls and are able to do everything in case of security, just to protect your private data leakage, not visible in the internet, against that LLM was 10, which is especially for the AI gateway, that the pattern you want to control and how much. Okay, any questions?
Maybe you can tell us a little bit about the hardware resources, on how much should we have to run like a system like this entirely, like an estimation. I know it depends on the model, on how big you want.
You're asking about the security or about the deployment of this AI?
Both. Combined, I don't know, or separate.
We have boxes, we have virtual machines, we have a containers in case of Nginx. In case of boxes, it's based on throughput. So you can buy, 1, 2, 5, 10 gigabits, up to 3.6 terabits per second. So it's scalable enough. In case of virtual machines, because it's a hardware, so we can offload a lot of, let's say, communication and a lot of functionality which can be CPU intensive, like decrypting SSL and encrypting SSL again to the interface cards. So in case of hardware, it's quite easy. In case of virtual machines, we are using virtual machines above the VMware KVM, so there can be access via SRIOV and DPDK, just to accelerate the communication, network communication. And in case of Nginx, it's just containers, so if you need more power, so you can deploy more containers easily based on the configuration file and almost nothing. So this is from the protection point of view. From let's say the consumption of the resources for this AI factory, it really depends how big is the database, how many customers you will allow to communicate on our platform. You can also control, how many calls per customer you can have per minute, for example, and so on. So in case of database, it's terabytes. Memory, you can deploy this small Llama 3.2 and this small ecosystem even on my laptop. It's not that difficult. But it depends, how much performance you need, because otherwise, if you want to have, the very fast response and everything, it must be built on the NVIDIA, for example, cards, chips. So it depends. it depends how many calls you expect, how big is the database.
If we want to raise this, where we can add in this diagram a load balancer to acquire more customers over the same resources?
I'm not sure if I understand exactly what is requested.
I mean, for sure we can reach some points where the traffic, data traffic will be higher. So where we can add the load balancer.
Usually to the, let's say, to the backend data store.
In the backend.
Yeah. Because from the front end, you know, it's just API calls. It is not, let's say, you don't need such a big performance and you know the bandwidth because it's not like the downloading the images or something like that. It's just text, so it's easy. Yeah, you can put it also here, but it is not necessary. But here you can see we have some load balancers. Yeah, in front of the AA factory, in front of the storages. Depends.
Remember that I saw the picture, but did not process it earlier.
Yeah. So it's it's already started. In some companies are using AI already, and some like planning. Some admins, are playing with the AI because it's easy to deploy. It's just containers, so you can download one Linux machine and deploy to the Docker inside and run this environment easily. If you don't expect, very fast response, it's enough.
Thank you.
Yes. So thank you very much. In case any questions, just reach me, or you can ask my colleague
To szukałem kabiny.